So in the first question, they just want you to find the mean and standard deviation. So to get that, first you type in your numbers, then we're doing stat calc, one var stats. My data's in list 1, I'll leave everything else. And mean is x bar. Just remember that standard deviation, we want the SX, always. If SX is there, we use it. We do not use the sigma one. And it would just be a point for each value for part A. Then for part B, they want you to interpret the standard deviation in context. So this is the generic version we wrote. Standard deviation is roughly the average distance from each point to the mean. In this problem, instead of each point to the mean, we still would say that standard deviation is roughly the average distance, but now it's from the number of assignments each student completes to the mean number of assignments completed, because we are talking about the number of assignments completed in his class. So you'd get 1 point for having roughly with the average distance, so those two together are 2 points. Then from each point to the mean, like the equivalent to that is a point, and then you do get 1 point for your context. So if you would have this one, you would get 3 points because you'd have no context, but everything else would be correct. Adding that context as a 4th point. Okay, next I said to make a dot plot. So again, look at your numbers, look how low they go, look how high they go, and get your points on there. So you do need to have a scale consistently labeled, that's a point. You do need to have your graph there with a label to get your other 2 points. Okay, now to make a histogram, one of the things I would suggest you do is take your data and sort it. So if we go to stat and then choose number 2, just make sure you tell your list which list you want to sort, and then enter. And the reason I say to do that is once this is in order, it's a little bit easier to now make a table. And in this case, they told you to make a class size of 2 starting with 10. So my classes are going to be 10 to 12, 12 to 14, 14 to 16, all the way on down. If you have those numbers sorted, then you can just start counting. 10 to 12, I really only have one number because I'm going to put 12 in the 12 to 14 class. Then from 12 to 14, I have the number 12, but that's it. So I only have one number there. Oops. Then from 14 to 16, I have nothing. The number 16 is going to go into that next biggest one. 16 to 18, I have 16 and 17, but then 18 we get bumped up, so I have 2 there. In the 18 to 20, I have this 18, this 19, this 19, but then I hit my 20, which would go in the next one. From 20 to 22, I have 1, 2, 3, 4, 5, 6, 7, 8, but then I hit 22, so there's 8 in that range. And then I have 22, 22, 22, so I've got 3 in that final box. So there's my histogram. I've got so when it comes to the points, first of all, my x-axis is correct. I have the break, then I had 8 just squeezed in there, but starting at 10 up to 24. My scale is consistent. I have it marked every 2. My x-axis labels the number of assignments. My y-axis labels either frequency or counts. And then, in general, just making sure your graph matches your data. You don't technically have to make this table if they just say to make the histogram, but I do think it helps to organize things. Now, in addition to making the histogram, we need to describe it. But describe, by now, hopefully you're comfortable with the fact that describe is actually a loaded question. If we're going to describe, we really need to cuss. So the center of the histogram is at 20. And I actually have that I can do that from the one var stats. If you didn't have the actual data, if you were just going from the histogram, then you would have to just eyeball it and say that the center is between 20 and 22. But here I said the center is 20. There are no unusual points. Shape is skew left. And then for the spread, because I'm looking at the histogram, I had my spread go all the way from 10 to 24. If you actually said it was from 10 to 22, which is actually what from the data, that would be okay too. But make sure you say the spread is from the min to the max, which is a range of, and then do the subtraction. 24 minus 10 gives us 14. Okay, next we have a new set of data. This is ages of a random sample of students taking a statistics class at the University of Minnesota. So first we want to make a split stem plot. So split stem plot means we're repeating stems. Now, if you have 2 1s here, that's great and wonderful. I don't have any numbers in the low teens, so I didn't include that first one because I didn't need it. But if you had it there, that would be just fine. Once we start our stems, though, we need to repeat them all, regardless of whether they have data or not. So here is my split stem plot, and we do see there is a jump. There's no numbers in the upper 30s or in the lower 40s, but I can't leave them off. I need to keep those there. So you get 1 point for the key, 1 point if you split them correctly, 1 point for having just the graph there, the data in the right spots, and then 1 making sure you go from smallest to largest with your leaves. And then if we're going to describe this, one way to think about this is if you turned it this way, that'll help with your skew right, skew left. So the center is at 22.5. I got that by just typing the numbers in and then hitting my one-var stats. If you just eyeballed it and said the center is around 22 or 21 or 20, that would be okay. There are no unusual points. Oh, no, there is an unusual point. There's an outlier at 48. Then the shape is skew right. The spread of the data is from 17 to 48, a range of 31. So each of those is a point, and then you get 1 for doing sentences. So that cussing there is 5 points total. First set of data is the same data we had at the very start for Mr. Johnson's statistics class. And basically all we need to do is do our one var stats with list 1. And I need to go all the way to the bottom because I need the quartiles. So then I would take, the first thing I do is take I figured out 1.5 times IQR. IQR is just Q3 minus Q1, so 21 minus 18. So my 1.5 IQR is 4.5, and then I want to do Q1 minus that number. So Q1 is 18 minus that 4.5. That's going to give me my lower fence, or my lower boundary. Then I also want to do Q3 plus 1.5 IQR. And the important thing is, yes, these two numbers are important, but you need to explain why. So anything not between 13.5 and 25.5 is an outlier. And then because of that, now I can look at my data and say, oh, okay, well then 10 and 12 are outliers. There's nothing higher than 25.5 in this list, but 10 and 12 are both below 13.5. To do the same thing for the pre-calculus data, you just need to enter those numbers in. I put them in list 2. So I got to change that to list 2. And then hit enter. And again, scroll all the way to the bottom. So 1.5 times IQR is 1.5 times 19 minus 14, which gives me 7.5. Then I want to do Q1, which is 14, minus 7.5. Q3 plus that 1.5 IQR, that gives me 26.5. So then I would say anything not between 6.5 and 26.5 is an outlier. And this time, that means there are no outliers. All of our numbers are between 6.5 and 26.5, so we don't have any outliers in that data. So when it comes to points for these problems, you get 1 point for somewhere showing me that what your 1.5 IQR is. You get another point for showing me what Q1 minus 1.5 IQR is, so I can see that value, and the same thing with Q3 plus 1.5 IQR. One of your points is for just explaining to me in a sentence what those numbers give you about those two values. That's the one that people miss a lot. And then 1 point is for identifying the correct outliers or writing that there are no outliers. So the other thing we need to do is make box plots. So what I'm going to do is I'm going to go into my calculator. And I'm going to have this first plot turned on, have it with this box plot with the outlier showing, and have that at list 1. But I'm also going to turn on that second plot and have that set up with L2 so that when I zoom 9, I can actually see both graphs on both box plots at the same time. And then you can use your trace button to arrow around and figure out for your scale, like, oh, well, my highest number is 22 for both lists. My lowest number is 10 and 10 as well. That will help you set up your scale. So I went from 10, I went all the way to 24, but you could have stopped at 22. Then just trace your way through and mark off all those spots. Okay, So 2 points are just for having your scale correct and that it's one scale, not a scale for this one and then underneath it you have a whole separate graph, but the both box plots on the same scale. You need to label both what the variable is, the number of assignments complete, but you also need to label which graph is which. This data came from Mr. Johnson's stats class. This data came from Mr. Johnson's pre-calculus class. After I fix that typo. And then now if we're going to compare. When you are comparing, if you hit all the things of CUS, that's fine. Center, shape, and spread tend to be the ones we look at the most. And with box plots, shape can be dicey. So for sure, you need to talk about center and you need to talk about spread. So for the spread, or for the center, you can talk about the medians. The median for stats is higher than the median for pre-calculus. I think it's even a little bit stronger if you compare other more noticeable things that are involved with center. So the center for stats is 20, and that's higher than even Q3 of pre-calculus, which is 19. So we're still talking about center. Quartiles are also measure center, but by pointing out the median's bigger than Q3, that kind of gives us even a little bit more insight into how much larger the stats values are. Then for spread, you can look at overall range or you can look at IQR. Because I have some outliers here, I'm going to avoid range altogether, and I'm going to talk IQR. So the IQR for pre-calculus is 5, which is larger than the IQR of stats, which is 3. So they are a comparison. I talked higher and I talked larger. I talked higher and I talked larger. And then I've compared center and I've compared spread. If you talked about shape, stats is probably slightly skew left because this tail's bigger than that tail and that side of the box bigger than that box. Pre-calculus is probably fairly close to symmetric or maybe slightly skew left, but box plots are so hard with shape. Your points are for talking about center somewhere and talking about spread, because at the least you have to talk about those. And then in general, if you have two statements, you get 1 point if the first one's correct, 1 point if the second one's correct, and then 1 point for actually comparing, not just stating two facts, but actually comparing that this is larger than this or smaller than that or whatever. Next, find the mean, standard deviation, and 5-number summary for the pre-calculus class. So that's just a matter of running one of our stats, probably again, because you've probably already done it. Mean is 16.44, standard deviation is 3.43. And then for the 5-number summary, we are just scrolling on down to get those. 1 point for the mean, 1 point for the standard deviation, 1 point for the 5-number summary. And then last but not least, this is probably more how you'd see this kind of question. I didn't love the way I had it set up on the worksheet originally. But if you had here they give you the stats for a large random sample of state parks. This is the number of campsites available at a large sample of parks. And if all we know is the mean in the 5-number summary, what percent of the data is between 43.5 and 78? Well, 43.5 is the 50th percentile. 78 is the 75th percentile, so there would be 25% of our data between those two values when you're talking about a large sample. Number 2 wants to know about between 62.8, which is the mean, and 78. And if we don't have enough information to know what percent of the data is between the mean and any of those values. 28 and 275 is Q1 to the max, which is 25th percentile to the 100th percentile, so that'd be 75%. 0 is the 0th percentile, the minimum, and 43.5 is the median, so that would be half of our data. And then 28 to 78 is really the 25th percentile to the 75th percentile, so that would be 50% of our data between those two values. So hopefully that helps clear up anything that still was unclear. Hopefully it went well and you were able to improve on our first attempt when we did this. If you have any questions, let me know.